so the winner is yellow. And if yellow press, winner is magenta. This project is sponsored by PCBWay. From concept to production, PCBWay provide cutting-edge electronic design solutions for global innovators including hardware design, software development, mechanical design, product testing, and certification. PCBWay engineering team consists of experienced engineers in electronics, embedded systems, and product development. They successfully delivered hundreds of projects across industries such as medical devices, industrial automation, consumer electronics, smart home, and IoT. Hello, Arcade Reaction Game is a genre to play designed to test a player's physical response time and hand-eye coordination against increasingly difficult visual or auditory cues. These games are usually that simple: a single button, a joystick, or a touchscreen, and anyone can play it immediately, but mastering the timing is the real challenge. This time I will present you with a way to make such a game using an Arduino microcontroller and WS2812B type of LED strips. This game is designed for 2 players, and the basic goal is to press a button as quickly as possible immediately after a certain color appears on the LED strips. It is the simplicity and speed of play that make this game very addictive. In fact, I used the complete hardware from one of my previous projects, actually VooMatter, adapting the code for this purpose. The device is really simple to make and consists of only a few components: Arduino Nano microcontroller board, next 2 LED strips with 50 LEDs each of the WS2812B type, 3 buttons, player 1, player 2 and start button, small speaker and 2 potentiometers. The entire device is mounted in PVC housings, and the 2 buttons for the players are large, robust ones that I made specifically for these kinds of arcade games. The code uses Adafruit NeoPixel library, and it is designed in a way that allows you to change all settings and options very easily. Specifically in this case, I use Arduino IDE version 1.8.15 and the latest version of the Adafruit NeoPixel library. First, let me describe the method and rules of the game. At the beginning, when starting both strips, a simple animation appears accompanied by appropriate sounds. The left bar and button represents player 1 and the right side represents player 2. By pressing the start button, the first 3 LEDs on both strips begin to alternately light up with green and blue, which is a sign that the game has started. After this, from the 3rd to 8th second, at some point all the LEDs 6 will light up red. This is the moment when the player should press immediately the button. The first to press the button is the winner of the individual game. If any of the players presses the button before the red LEDs appear, they automatically lose the game. The next game begins by pressing the start button again. A complete game ends when the one player is the first to win 5 individual games. The result is displayed by the top 5 LEDs. With the appropriate color, player 1 is yellow and player 2 magenta. The winner of the complete game is indicated by flashing all the LEDs with the winning color and the corresponding winning sound sequence. Since the game is based on reaction speed, it is desirable that the reaction time can also be displayed somehow on the strips. For this purpose, I use the select potentiometer. In the extreme left position, the active scale 40 LEDs represents a time of 10 milliseconds. 4 LEDs approximately indicate 1 millisecond, and in the extreme right position, the scale displays a time of 1 second. At the end of any individual game, we can zoom the time with this potentiometer. So we can very precisely determine the reaction time of the two players, theoretically with an accuracy of 0.25 milliseconds. This will become clearer to you during the specific demonstration game that you will watch below. For example, player 1 reacted for about 3.5 milliseconds. Now let's see what the gameplay looks like in reality. First, we set the potentiometer, the left potentiometer, approximately in the middle, where the entire scale represents a time of half a second. Next, press on button and the device is ready. When we are ready for playing, we need to press start button. The right potentiometer changes the intensity of LEDs from 0 to maximum. Now we'll start playing. Player 2 wins with about 4 milliseconds difference in reaction. About 16 LEDs. Next game. Now player 1 wins and the difference is bigger, about 5 milliseconds and more, 6 milliseconds. Next game. Player 2 wins. Again, player 2 wins. Player 1 wins. With big difference. Player 2 wins with difference of about 3 milliseconds, 12 LEDs. And finally, winner is player 2, magenta. Player 2 wins with 5-2. If we like to start new game, we press start button again. If any player presses the button before the red LED lights up, the player automatically loses the game. Yellow player is winner. Or opposite, now magenta player is winner. Finally, a short conclusion. This project transforms basic components like LED strips and Arduino into a professional grade arcade experience that tests the limits of human reaction time. It is the perfect blend of simple mechanics and high precision engineering, making it a great addition to any do-it-yourself game collection.